Hey everybody, welcome back. So have you ever been, fooling around on Thingiverse or YouTube in the 3D printing channels and find something so cool that you just had to print it? You don't really need it, but nonetheless, it's just so neat looking that you just had to make one. And that's where I'm at right now. You guys may remember, if you watched my last couple of videos, I talked about that little Harbor Freight 2-inch chop saw, and then the little adapter I made to put 300 or to put 556 brass on it to trim it down to make 300 blackout. And while you guys may not be interested in guns and reloading, this is just such a cool little tool that can be used for so many different things. I have the commercial version of this. I bought it a long time ago, and I just don't need this, but I just thought it was such a neat project that I just have to try it. So let's pop over to Thingiverse real quick and let's take a look at what I'm talking about. And let me see what my dog is barking about too. Be right back.
Here's the thing I'm talking about. It is a copy of the Frankfurt Arsenal case prep and deburring station. It's got 4 tool stations, and they use an inside-outside deburring tools, and then a primer pocket cleaner and scraper. And you can put any tool on there you want, and it spins about between 100 and 300 RPM. And this part is by MSG Bean, and this is from January of this year, believe it or not. And as you can see, it's got quite a bit of parts to it. There have been 2 remixes of it, and I have them open here and here. And all this guy here did, Corey D, all he did was modify this to make the bearing holes larger without making the rest of it larger. And this guy here made a couple of new pieces, and also, and this guy is KRS-Creations. I want to give everybody credit. I didn't design anything on any of this, so this is somebody else's stuff. And all he did was he took the display out because he didn't feel he needed the RPM display with the RPM controller on it. And he also made a couple of other little changes, which I'm going to incorporate parts from all 3 of these, because he uses, in this one, he made a part that requires that you come up with 832 coupler nuts, and I couldn't find any locally. And on Amazon, if you want to buy 10 of them, it'll cost you $30, and I didn't want to spend that. And also the tooling, if you don't have this tooling and you'll want the tooling, you can buy a $25 Lyman handheld tool and get this tooling on it with the correct threads and everything on it. And if you want to use it for something else, certainly make your own tooling or adapt your own tooling for it. The motor, and let me pop back out to the and also the original one. I just want to mention, he has a video in here too where he talks about it and disassembles it, and it's worthwhile to watch it to see how he did what he did. But let's pop out, let's see what I've got printed, and I'm going to try and put it together and see what I think about it.
Okay, with that being said, I think I actually have all the parts printed. And as you can see, I printed the gears and the little stub shafts in white. I printed this on my Geeetech A10M, and I've got it's a dual filament printer, and I've got black PLA Plus on one side and white PLA Plus on the other. I was too lazy to change it, so what I did is I printed some parts out of the white, I printed a couple of parts out of the black, and then some of the parts I just mixed it. So did a 50-50 mix. So I've got the motor. This motor is $12.95 on Amazon. I'll put a link to it below. If you download the original thing, he's got a PDF file in there with links. My links will be affiliate links. If you don't want to use them, get the PDF out of his thing, and he's got links and descriptions of everything in there. $12.95. It's a 3,500 RPM motor with a gearbox on it. Whoops, sorry. It's a 3,500 RPM motor with a gearbox that turns it down, that slows it down to 100 RPM. Now, the gearing in it speeds it back up to 200. So, he used quarter 20, where's the other bolt? Oh well, it's around here someplace. I had 4. He uses quarter 20 bolts to hold it together, quarter 20 nuts, and he used quarter 20 because here in the US quarter 20 is cheap and everybody's got quarter 20 bolts, even ones this long. It takes some smaller metric screws to hold to hold the motor into the case, and just some other odds and ends of little nuts and bolts. Now, he recommended you use 8x32 coupler nuts. As I mentioned, I couldn't find them. I don't want to spend the money on Amazon. He couldn't find them either, so he used 8x32 lock nuts and simply put two together on the tools. The One Remix, he makes these parts here. He makes it one piece, but it suggests you do a pause at height, drop the coupler nut in, and then restart the print over top of it. And you can do that if you want, but without the coupler nuts, I think you're better off doing it the original way. I also printed everything at 3% oversize. I found that for me to be the best compromise between these holes being too small for 1/4-20 and then these starting to be too large really for the bearings. And you can always use some kind of glue to hold the bearings in. Obviously, at 100 or 200 RPM, I'm not really worried about the bearings spinning a little, so that doesn't concern me too much. Can't think of anything else I really wanted to say about it. Oh, I also bought the power supply he recommended for $8. I mean, the fasteners were all about $8. The power supply is about $8. The motor's $12.95. If you have to buy the Lyman kit to get the tools, you're still under $50. The Frankfurt Arsenal tool, lowest I could find it when I was looking around recently, was about $120, and that was from eBay, and the shipping was not free on that one. So you're saving at least $70 by doing this if you want something like this. So I'm going to shut up now, and I'm going to try put it all together. I have already done some fitting where I have run 1/4-20 drill down here just to clean the holes up and everything. And this lid is unnecessary. You don't have to print this. I printed it halfway just to keep all the parts together. But you don't have to print the lid. And yeah, let me see if I can get it together. Oh, if you don't have the skate bearings, I think you can buy 20 skate bearings for $5 on eBay. They're dirt cheap. Anyway, let me shut up and let me see if I can put this together. Be right back. Okay, I got the motor mounted. That was easy enough to do. I had to clean up the holes a little bit, but I've got 4 screws mounting the motor in. As far as the power is concerned, the barrel plug that comes with that power supply, I just opened this hole up a little bit and pushed it in, and it is pretty tight. Where is the power supply? What did I do with that? Here it is. So I just shoved that little rubber end in there, and you can plug it. I can plug it in and out. Am I on camera? I can plug it in and out, and I think that'll work just fine. A person could just cut the end off of this and wire this directly to the motor. Just use a grommet in the hole and some silicone sealer, or not even any sealer at all, but I'd put some kind of strain relief in it if I did that, and just plug it in to turn it on and unplug it to turn it off. And the power supply might be useful for something else, but then again, I might just lose it if it's not plugged in all the time. As far as the switch is concerned, the square hole is for a rocker switch, and the round hole is for an LED. I don't have an LED that'll run off 12 volts, and I don't think I need an LED to tell me the thing is running. The only rocker switch I have is a lit one. It's meant for 115 volts, and it will not light up under 12. It's also kind of big. I do have one of these and some appropriate washers, and I think, like I say, you can just use the power plug to turn it on and off. I think I'll put the switch in since I have it, and yeah, I think that's what I'm going to do. Okay, so here is the wiring for those of you who want to see it. It is really simple, and yes, in this particular instance, I am actually switching the positive side of the circuit. A couple of you have criticized me in the past for switching the negative side, and I forget who taught me many years ago in automotive to switch the negative side of the circuit. But anyway, doing the positive side here, you'll be happy to see, and got a couple of the bolts in it just to help me hold it together, and I stuck the gear on the motor shaft, so let's try it. I put some super glue around there just to make sure it stays in. It's not quite hardened yet, and here we go. I have the switch upside down, don't I? Yes, I have the switch upside down. I'll fix that. And there we go. So, wiring is right. I just want to rotate that switch around so that off is down, not up. Not sure how I got that in backwards, but I will fix that and be right back. Okay, I have my bottom on and the bolts in, and my skate bearings in. Skate bearings fit in nice. And now these little stub shafts, whatever you want to call them, they need to go into, can you see it? They need to go into the skate bearings like that, and then another skate bearing goes over top, and right now they're a little too big. So I have a drill motor and a file and some sandpaper, and I'm going to see if I can kind of shave those down to fit. Okay, so that was lots of fun, but I noticed that somehow, obviously through my own fault, my cure settings, what I have set for initial horizontal expansion and whole horizontal expansion, had all been reset to 0, and that caused me to have to do just a wee bit more hand fitting than I would have cared for. And I did reprint these stub shafts because they just were going to require way too much hand fitting, and I reprinted the four planetary gears with the correct whole horizontal expansion, which I typically use as 0.3 and then negative 0.2 for initial layer horizontal expansion. That just means you don't have to file that little bulge at the bottom that sometimes you get, or at least I seem to get, off. And I think I've got everything else fitted. When we turn the power on, all the gears spin the way we'd like them to. I mean, they kind of wobble around a bit, but there's going to be another bearing plate on the top. And that's when I noticed I created another problem for myself. By creating this at 103%, I seem to have thrown the height off to the point where, if you look at it, see, these two plates also have to go on. And this one goes on. Then this one, this spacer goes on, I think. Then these two go on. And I've reached a height where I have no more threads left to put the nuts on. So somewhere along the line, I am going to have to, I think what I'm going to do is just print another one of these, just thinner. And the next piece that goes on is this one. And this one's to fit through that shaft, and I don't know whether it does or not, but what I'm going to do is I'm just going to open it up enough so that I'm sure that when I push this down on and put the other bearings in, that I'm good to go, and then I will decide the thickness of this. So be right. Okay, so I have this top plate on, the top plate with the bearings, and as you can see, it all works. It's a little noisy, but the bearings don't fit tight. I may glue those in, and I may not worry about it. The next piece that goes on, and I think I can put these on next. These are the tool holders, and I had to do a bit of fitting on those too, and I shouldn't have. I could have just reprinted them, and that would have avoided the hand filing and fitting. But you know, by the time I realized that, I think these two need to be swapped. Unfortunately, yeah, there we go. Unfortunately, they wound up being individualized, which I didn't really like, but you know what? It happens sometimes. Now, this plate sits on top of there, and as you can see here, can you see? I'm not going to have enough. I'm not going to have enough thread sticking out because I made the 3% over, or somebody else's calculations were off. I thought the 3% wasn't going to make more than a few millimeters of difference, and I was apparently wrong. So I'm going to have to do something, and I think one thing that could happen, I think this is supposed to go down around there, if I remember correctly, and then that's what these pieces were for, were to keep you know, particles from falling down in there. So the first thing I'm going to do is open these holes up so they'll drop in around that tool holder part, because right now they won't. Well, maybe they will. So what's going on here? Oh, maybe these holes. Have I not opened those up? I got to open these up. Be right back. Okay, so I think we're ready to put this thing the rest of the way together, and it's about time. It's 5 o'clock. I've been working on this thing on and off all day long, and I'm thoroughly sick of it already. So, not already, it's 5 o'clock. Anyway, I reprinted these little tool holder parts because the nuts wouldn't fit down in them, and I just didn't feel like doing any more hand fitting. This upper spacer, I printed a slightly smaller one. I think I took 3 or 4 millimeters off it to make up for the fact that I made a mistake of making my Z size 3 millimeters longer, or excuse me, 3% longer, and then the studs weren't long enough. At one point in time I was thinking about reprinting the whole thing, but you know, it's mostly together now. So I decided just to make this smaller and see if I couldn't get away with that. So these are in place. Just remember, when you make this, if you print oversize, don't print. When you raise the percentage up, don't raise the Z percentage up as well, or your bolts won't be long enough. Also, make sure you have the horizontal hole expansion set to about 0.3 millimeters, and that will help, as well as horizontal expansion set to about -1 or 2. That'll also help. So let's put it together now. There goes up. Nope, we got to put the spacer in first, don't we? I'm trying to do this wrong. That's okay. As Big Clive says, not to worry. All right. And you'll notice that the ones in the Thingiverse things, they show it with the bolts going down through that way. And I have to admit, while that kind of looks cleaner, I'm not really convinced that it's the best way to do it. I think I'm going to leave the nuts on the top. That way, if you need to replace something here, you don't got to pull the bolts all the way out of it. Anyway, it does look cleaner that way though, and I printed several sets of these little dust covers because again, I just didn't feel like filing anything to get it down. So we'll set those down, and I printed 4 at a time because it's faster that way because the my printer prints these quicker than it takes the automatic bed level system to level the bed at the start of every print. Now you don't got to run it at the start of every print, but I do. So let's get the nuts on it. Oops. I'll put everything back in the bag because I wanted to test fit the lid that I had all the parts setting in. So I should be long enough now. Just going to kind of snug them up a little bit and then use, I think I made that mid spacer about the perfect height. And there you have it, ready to spin tools. I think let's try the nut. The nut should fit right in, and it does. So I'm ready to go. I'm ready to put some tools, double nut my 832 threaded tool ends, and I'm ready to put the tools in. Now let's see if the top fits. Yeah, I test fitted it and it seemed kind of tight. Oh well, at least you know it won't fall off. You know how 3D printed stuff is. A few times on and off, and it'll be fine. So there you have it. Let me go grab some tooling. We'll stick some tooling in it and we'll take it for a test drive. Okay, here we go. So I actually did break down and buy the Lyman Case Prep multi-tool for 25 bucks off Amazon. I did it for a couple reasons. One, I really would like to test this build the way, you know, the guy designed it to be. And secondly, I really don't want to cannibalize my other one to get this one working. So, and besides, it'll be nice to have 2 of them. Why, I don't know, but it'll be nice anyway. So, this tool, it splits into halves. It's got the inside reamer, the outside reamer, and then it's got the 2 primer pocket sets. One for cleaning the primer pocket and one for removing the crimp if you're using once-fired military brass. So, I'm going to get it out. I'm going to get the tools double nutted and on the machine, and I'll be right back. Okay, this is my second take of this part of the video because the first time I did it, I had my hand in front of the camera the whole time and you couldn't see a damn thing, so I'm going to just try and do it again. That's why things look different and maybe look messy, because I got so frustrated by the time I noticed it, I said to hell with it, and I went and worked on my old Jeep CJ7 for a few days before I came back to finish it. Okay, so I think all I have to do now is just show you it works and see if it'll hold up. So I have done the previous 10, and actually I did more than that in between, but that's why it looks a little messy. But I've got 10 more here, might be 11. Let's do them. This time I'm not going to have my hand in front of the camera. Let me make sure we're there and kind of sort of focused. It looks good, so let's do them. And for those, if I didn't say it before in the other video, the process of this is you trim them off in a little cut-off saw to, 1 or 2 millimeters too long. Then they go in the sizing die that sizes the outside of the case, and it puts a slight bottleneck on it, and it knocks the old primer out. And then you take it and I put it on a little hand crank trimmer that trims it down to the exact length I want. Now we do the deburring process. So here we go. I'm going to do case mouth first, inside and outside. Then I'm going to flip it over and I'm going to do the primer pocket. And I'm going to do that on all 10. Okay, so there you have it. I did, what was that, 3, 4, 5, 6, 7, 8, 9, 10. That was 11, I think. And you can see I've got a fair amount of shavings on top of it from it, but let's zoom back out and let's take a look at one of them or two of them and let's see what they look like. So there's our case mouth, nicely done inside and outside. There are no sharp edges there at all, very nicely done. And is our primer pocket, all cleaned, and I don't think either of these are military. These came out of my range collection, so if they're military, they had a crimp on them because I haven't done anything with these cases yet. So anyway, that worked really good. There you go. I will put a link to, Amazon links, and they will be affiliate links, but I will put Amazon links to the things that you can get from Amazon and a bill of materials to what I used. And of course, if you don't like affiliate links, don't use them. And your local hardware store will have the quarter 20 bolts and things like that. If you find coupler nuts, you might try the other design that uses them, but this seems to work perfectly for me. And I'm going to get on with it. Nice to talk to you guys again. The weekend is about over for me. This project, I put it off, like I say, for a few days when I got annoyed with it for having my hand in the camera. But other than that, it's all done. It's ready to go. The lid fits on it. And I'm ready for the next time. Hope you guys enjoyed this video. Please like and subscribe, hit notifications, and I'll put links below, and I'll catch you the next time. Bye for now.